Do you know how to print matrix in spiral order? If your answer to this question is no, then my friend, this video is for you. So please watch this video till the end. Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about how to print matrix in spiral order. So let's get started. Alright, let's have a look at this problem. In this problem we are given a matrix and our task is to print matrix in spiral order. So for those who don't know what does it mean by spiral order, let me show you. So if you look at this diagram, you will see that this is known as spiral order. So it starts from the outer layer, then going to inner layer, then inner layer, then inner layer. This is what spiral order looks like. Now we have to apply the same order while traversing the matrix. So let's understand this problem with example. Here the input is given as 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, 11, 13, 14, 15, 16. And this is a 4 cross 4 matrix. This means there are 4 rows and 4 columns in this matrix. So when we apply the spiral order in this matrix and start traversing this matrix, then the output of this matrix comes out to be 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5, 6, 7, 11 and 10. And how is it possible? First, we are printing the outer layer of this matrix. So it comes out to be 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, and 9 in 5. Then we go to inner layer of this matrix. And in inner layer, the elements are 6 and 7, 11 and 10. So that is why we get output like this. Now let's see the next example. In this example, we have only 1 row and 3 columns. So in this case, we have to print all the elements one after the another. Let's see the next example. In this example, we have only 1 column and 3 rows. In this case also, we have to just print all the elements. So by now, I hope guys you understood what does it mean by spiral order and how to traverse a matrix in spiral order and print all the variable you encounter while traversing. With this, let's move to the next section of this video and where we understand what is actually happening here. Okay, let's begin. So to print the outer layer of the matrix, what we have to do? First we have to print the top row of this matrix. Then we have to print right column of the matrix. Then we have to print bottom row of the matrix, and then at last we have to print left column of this matrix. Okay, so let's begin with the first step, that is printing the top row. So to print the top row, and that is 1, 2, 3, 4, we need 3 things. So the first thing is which row or column you want to traverse. So in this case, we want to traverse the first row. Okay, and that row is going to be the top row. And the second and third thing is how you are going to traverse. Are you going to traverse from left to right, or we want to traverse from top to bottom? So in this case, for first row, we want to traverse it from left to right. To store these 3 information, we need 3 variables. So let's call it top, right and left, and initialize these 3 variables with top equal to 0, and this indicates that we are traversing top row, and right is equal to c minus 1. And what is c? C is equal to number of columns. Here we have 4 columns, so the value of right is c minus 1, that is 3. Okay, and the value of left is 0. So this tells us that we are traversing top row from left to right. Okay, so let's traverse the row from left to right and print all the elements one by one. So we get 1, 2, 3 and 4. Now after the traversal and after printing all the elements, we never wish to visit this row again. So to store that information, what we do? We simply increment the top counter plus 1. So this means in future we never wish to visit this row again. Okay, now the value of top becomes 1. Okay, so first thing is done. Now the second thing is we want to print all the elements of the rightmost column. Okay, and this time we are going to print all the elements from top to bottom. So this means we again need 3 variables. First variable tells that what to traverse, meaning row or column, and second and third variable tells that whether you want to traverse from left to right or top to bottom. So we already have 2 variables top and right. So we need one more variable and we call it bottom. And we initialize this bottom to r-1. And what is r here? R is number of rows. So here you can see that there are 4 rows. So the index of this row is r-1. So this time we are going to consider the last column and we are going to traverse last column from top to bottom. So after traversing we get 8, 12 and 16. So far so clear. Now again, after printing all the variables, we never wish to come to this column in the future. So what we do? We move the right pointer to the left. Now it becomes c-2. I hope this is clear to you. The next step is now we have to print the bottom row. Okay? And how we are going to print this? In reverse order from right to left. And after traversing the bottom row, the number we get as 15, 14 and 13. And similarly, after printing all the elements of bottom row, we never wish to visit this row again in the future. So what we do? We simply move the bottom pointer to up. So 3 things are done. Top row is done, rightmost column is done and bottom row is done. Now it's turn for the left column. Now the left column we have to traverse from bottom to top instead of top to bottom. Okay? So let's traverse these elements from bottom to top. We get 9 and 5. And similarly, again, after printing these 2 elements, we never wish to come to this column in the future. So what we do? We move the left pointer to right. So guys, if you observe what is happening here, you will see that we have covered all the outer elements of this matrix. 1, 2, 3, 4 is done, 8, 12, 16 is done, 15, 14, 13 is done and 9 and 5 is done. Now it's time to traverse inner layer of this matrix. And all the pointers are at position 1, at position here, and you can see that all the pointers are here, here, here and here. This means now this pointer is targeting the inner elements. These are 6, 7, 11 and 10. So let's repeat the same process once again. So now let's consider the top row and print it from left to right. So after printing top row we get 6 and 7. Okay? And similarly, once the printing is done, we move the pointer top to next row. Okay? And the value of this top pointer becomes 2. Now 6 and 7 got printed. Now let's move to the rightmost column. In rightmost column, we have to print from top to bottom. And now top is at 2 and bottom is also at 2. So this means we have to only print this element 11. So 11 gets printed on the screen. And similarly, once 11 gets printed on the screen, we move the right pointer to the left because we do not wish to come to this element in the future. So the rightmost column is done. Now it's time to print bottom row, and we print bottom row from right to left in reverse order. So this time right is pointing to this place and left is also pointing to this place. This means we only have to print element 10 from bottom to top, and bottom and top is also at the position 2. So all these pointers are targeting only one element this time, and that is 10. So 10 gets printed on the screen. So guys, if you observe closely what we have done so far, you will see that we are using 4 pointers, and that 4 pointers tells us what to visit and how to visit, as in whether you want to visit row or column, and how you are going to visit from left to right or top to bottom. So I hope by now everything is clear to you. Now let's use the same approach, same observations, and convert this observation into the code. So let's move on to the next section where we see the implementation of this idea. So here you can see we have written a function. This function takes matrix as input. In the first statement we are getting length of row and length of column. Okay, in this example both are same. R is equal to 4 and C is also equal to 4. Correct? Moving on. Then we are initializing 4 variables: top, left, right and bottom. We are initializing top with 0, left with 0, right with C-1 and bottom is equal to R-1. Okay, if C and R is equal to 4, then right and bottom is equal to 3. So far so clear. Then we are running a while loop, and in this while loop we are checking if left is less than equal to right and top is less than equal to bottom. And why we are checking this condition? Because we want to stop when right and left cross each other and top and bottom cross each other. If right and left cross each other and top and bottom cross each other, this means there are no element left in the matrix. So we have to stop. Okay, clear. Now inside this while loop, we are again running a for loop to print the top row of the matrix. And we are printing top row from left to right. And then we are incrementing top by 1. Okay. As I said that we never wish to come to this top row in the future. So we increment top by 1. That indicates that now we are not going to traverse this top row again. In next for loop, we are printing rightmost column from top to bottom and then decrementing right by 1. So we are moving right from this location to this location. Okay. In third for loop, first we are checking if left is less than equal to right. And why is it so? Because might be possible that we get matrix smaller than this matrix having only 4 elements. In that case, our first for two loops makes the left and right cross each other. So that is why we are checking here that if left and right is away from each other, then only we are going to run this loop. Okay. And in this loop, we are printing bottom row from right to left. You can see here bottom row from right to left, and then we are decrementing bottom by 1. So before the bottom was here, now bottom is here. Okay. And in the last loop, again we are checking if top and bottom are away from each other. If it is so, then we are running loop to print leftmost column, okay, leftmost column from bottom to top. And then we are incrementing left by 1. So initially left was here, now left is here. I hope this function is clear to you. Now in the next iteration, again we are printing the top row that covers 6 and 7, then rightmost column that covers 11, and bottom row that covers 10. And after all of these iterations, maybe left cross each other or top cross each other, and then we simply stop. And after traversing the matrix in spiral order, we get numbers like 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, 9, 5, 6, 7, 11 and 10. So by now I hope you understood how this function is working and how we are printing matrix in spiral order. So this brings us to the next section, that is calculating time and space complexity. So guys, if you look at this approach carefully, we are printing all the elements at least once. So this means we are traversing the entire matrix and all the elements once only. And how many elements are there? It's simple. Number of elements is equal to R cross C. If rows are 4 and columns are 3, then the number of elements would be R cross C. Okay. And what about the space complexity? We are not using any extra space. So the space complexity comes out to be theta of 1. This means constant space. So overall, this approach took the theta of R into C time and theta of 1 constant space to print elements of the matrix in spiral order. And we have to say this algorithm does pretty good job so far. So guys, on this note, let's end this video. So if you learned something valuable from this video, then hit the like button to make YouTube algorithm happy. And please subscribe to this channel and do not forget to click the bell icon so my friend you never miss any upcoming video. So this is all from my side. Thanks for watching. See you in the next one.